Hello students. So this is our fourth class on heat and its effect. Today mainly we will discuss about effects of heat, that means how heat affects different states of matter. So we know there are three states of matter. These are solid, liquid and gas. So how heat affects these different states of matter, okay, and how we implement these technologies in our daily life and daily machinery things, whatever we see, for example bridge, railway tracks, in these things how we implement these features of heat, today we will learn. So let us begin with effects of heat. So we know whenever we heat an object, many changes take place, right? The sentence is as simple as that if we heat something, for example if we heat some water, okay, you are trying to heat some water, what will happen? The first thing what will happen is the water temperature will rise, and before heating the temperature will be low, but after you start heating, what will happen? The water temperature will rise. Next will, after some time when the water starts boiling, okay, what will happen? Water vapors will come out, right? So different changes are taking place from heating. So today we'll in detail we'll learn these things. So to understand this, we'll do a simple activity, okay? So I'll draw the diagram here. If you face any problem, then tell me, I'll repeat. The first thing is, take a vessel and put few pieces of raw vegetables into it. That means we have to take a vessel, right? So I have taken one vessel, I have given some vegetable pieces on it, okay. Next, fill the vessel up to the brim with water and close tightly with a lid. So we are filling it with water. These drops are nothing but water. Then we are covering it with a lid, okay. We have covered it. Now what to do? We will heat it. So we are trying to heat it. So what are the different changes will take place now? Think, okay, don't go with the book text. Think what you can realize. If you start heating, what will do? After some time, what are the different changes that can be possible? As the water heats up further, it begins to overflow, that is volume increases. So if you start boiling by closing your container with a lid, what will happen? After some time, water overflow will take place, right? You might have seen these things whenever your mother tries to boil something in home. This phenomenon you have seen, that water overflows when boiling starts, right? That means water will overflow from this place. That is, volume is increasing. Thus, heat causes expansion. Now we can say that heat causes expansion because when we have started the boiling, we have filled the container with water, right? No water was overflowing, but after boiling the water for some time, now the water is overflowing. That means the water has expanded. It is heat cause expansion, okay. The next is, as the water boils, steams also come out of the vessel by pushing the lid. That is, water changes the state due to heat. So after some time, what will happen? Now water vapor, that is steam, will come out of the vessel. That means now the state is changed, right? Earlier the water was in solid state or liquid state. Which state? It was in liquid state, but the vapor or the steam is in gaseous state, okay. That means the water state is changing, okay. Now what will happen? Another change will take place. When you have started, we have given some piece of vegetable, right? These are vegetable pieces. These are normal, intact. Now after boiling, what will happen? The vegetables are cooked. That means we are just doing one thing. We are just applying heat, but three things are occurring. The first is volume increase. Next, heat causes. The next change is, it is changing from liquid state to gaseous stage, and the last change is vegetables are cooked. That means a number of changes takes place during heating. If you heat something, there are different changes will take place on the substance. So we can say that heat causes change in temperature, change in state, change in expansion and chemical changes. If you heat anything, what are different possibilities? The first is temperature will go increase, then change will increase. In this case, it is in changing from liquid to gaseous state. Then expansion. In the first point, we learned that due to heating, the water expanded, right? And chemical changes may also take place. So first, we will learn about how heat causes expansion in different states of matter, and then we will go for some examples. So now we know expansion is one of the effect of heat, right? All the substance, whether solid, liquid or gas, expand on heating and contract on cooling. That means whether it may be a solid or liquid or gas, if you heat it, it will expand. That means the size will expand, and if you cool it, the size will contract. For example, this is normal water, right? If you heat it, okay, if you heat it, what will happen? It will expand, right? It will change to vapor. That is, your size will expand. At the same time, if you cold it, what will happen? It will become ice. That means the size is contracting. So these are two phenomena. If you heat any substance, irrespective of solid, liquid and gas, the size will expand. If you cool something, the size will contract. Okay, now let's begin with solid. Expansion of solid. What happens in solid? The molecules of solid are closely packed. For example, how to understand this? Think about a chalk. Okay, the blackboard chalk with which we write. If you break a chalk, you will find there are small powder-like things, right? So these are nothing but molecules. Okay, for example, these are nothing but the molecules. But before breaking the chalk, all were packed together to form the chalk, right? All were packed together to form the chalk, and these are so closely packed that the one is not allowing the other to get out of the package, right? But as soon as you will break the bond, all are becoming dust. So what we can understand from this point, that what happens in solid? In solid, all the molecules are so tightly packed that one doesn't allow the other to leave. Okay, the space between the molecule is called intermolecular space. The space between the molecule is called intermolecular space, and this space, intermolecular space in solid, is so negligible that you cannot even measure this. Okay, thus if the space is too less, one will attract other, right? So the force of attraction is too high. So how to break this? Apply heat. What heat will do? Heat will break this force of attraction. Okay, and ultimately what will happen? They will expand. Okay, for example, iron is a solid metal, right? If you give normal heat to iron, what will happen? Nothing will happen. But if you give extreme heat to iron, the strong bonds, molecular bonds of iron will break and iron will melt. Similarly, gold, aluminium, all solid things, just think about the solid things. If you give them heat, high heat, what will happen? The intermolecular space, which is too less between them, it will increase and ultimately they will melt. The intermolecular bond will break down. Okay, so this is how expansion in solid takes place. Now let us discuss about expansion in liquids. So what are liquids? Water, oil. Okay, these all are liquids, right? If you compare liquid with our solid, we can say that liquid molecules are less closely packed than the your solids, right? Thus, space between the molecule is also more. For example, in solid, first I am doing solid. Okay, solid, the space between two molecules is so closely. For example, this is A and this is B, so connected. Okay, so the intermolecular space, the space between these two is known as intermolecular space, is so less. But what happens in liquid? The space is a bit more. So the intermolecular space is more. Okay, in case of liquid, as the molecules are a distance apart, so it is quite easy to break this. So if you put some little amount of heat, this starts breaking. So how to understand in which case the intermolecular bond is strong and in which case is weak. For example, in your home, in gas stove, if you put some water and if you give normal heat also, what will happen? The water will vaporize, right? It will change state, the intermolecular bonds will break down, it will get expanded, right? But in your home, if you try to melt an iron, can you do this? No, in your house normal stove you cannot melt an iron because it requires high temperature to break its intermolecular bond because they are so closely packed. Okay, so we can say that expansion of liquids is more easier than the solids. Okay, solid is more hard. If you compare and think about expansion, it's difficult, but in case of liquid it is very easy. Coming back to gas molecules are so closely packed. Okay, for example, if you have a gas light or in a home gas cylinder, if you just open them out, in 2 seconds all gas will evaporate. That means the molecules are so closely firmly connected that one cannot bound the other. Okay, all will separate. So in this case what will happen, it is quite easier to break the intermolecular bond, okay, by applying little amount of heat, very little amount of heat. Okay, so here the molecules are so firmly bounded. Okay, the intermolecular space is too high, the attraction is also very low, we can break the bonds very easily. So the expansion of gases is higher than your solid and liquid. So if you start giving rank, so the highest to lowest, okay, if you start to giving rank from highest expansion to lowest, okay, lowest what? Expansion. Our highest is what? Highest is your gaseous, next is your liquid, and last is your solid. Okay, so gas will show highest expansion, then liquid will show medium expansion, and solid will show the least expansion. Okay, so these are about expansion in these three different states of matter. Now we'll understand it more clearly with some examples. Expansion around us, which we see in our daily life, if you just observe these things you can relate. First thing is, you must have seen, okay, that one end of the steel bridge. Okay, so the very first example is in our near to our school there is one steel bridge, right? Just near to our school there is one steel bridge on Barak river. So if next time you visit the bridge, okay, if you travel by the nearby area, you just look at these two ends of the bridge from the side, you will see that there is some space between these. Why this space? Why they are not filling this space? Because they know that the scientist or the engineer which have developed this bridge, who have designed this bridge, they know that this is a steel is a solid matter, right? And this will expand on heating on summer when the heat on summer or winter days when on the daytime the temperature is too high, or in winter when the temperature is too low. What happens on summer? When the temperature is low, the metal will contract, and during high temperature it will expand. So if they have filled the gap, what will happen in this case? During expansion this bridge will break down, but now they have the gap. If it will expand up to this much, no problem, there is enough space, right? So this is the reason for which the engineers which have developed the bridge, they have given some gap between these two space. Okay, so now I think you can relate what expansion of materials means and how we can implement this to get rid of many problems. Because if the engineers have not given any gap over here, the bridge could break some 10-20 years ago. Okay, it could not have lasted so long. It is lasting because of this engineering technique that expansion will need some space, so we'll leave some space in between. So the next example is fire alarms. So how these fire alarms work? We see fire alarms, right? in every bank, every good big building, every good office, there is fire alarms. Whenever the building or the infrastructure catches fire, what will happen? In our school also there maybe there is fire alarm. Okay, what happens? Whenever there will be fire, the alarm will start ringing automatically, right? How this automation happens, how this is working automatically. So the fire alarm consists of two metal strips. Okay, one is iron, another one is brass. What happens? The fire alarm has two things, two metal strips. One is iron, another one is brass. So brass on heating, whenever fire will catch, what will happen? The temperature will rise, right? So if the temperature will rise, the metal will expand. So brass expands more than iron on heating. Whenever it will heat due to fire, the temperature will rise in the room. The brass will expand due to heating. When the brass tip is heated, it bends on the side of the iron strip. As it bends, the circuit of the bell is completed. The bell starts ringing to give an alarm. As the fire is put out, the strip gets cooled and the straight turns on again. So what will happen? Let me explain. When there is a fire in the room, okay, so what will happen? In the room the temperature will rise due to fire, and this high temperature will lead to the expansion of different metals. And brass is a metal which is present on the fire alarm machine. It expands quickly, so it will expand and it will touch the iron. For example, this is normal brass and this is iron. Okay, this is our iron, this is our brass, and this is switch. If you connect these two, then the alarm will ring. So when there is no fire, in this case no fire, so no connection, but it is normal iron and it is brass. Okay, it is during fire. So during fire what will happen? The brass will expand, it will touch to the iron and the circuit will complete and it will start ringing. So after the fire what will happen? Again temperature will down, right? Temperature will be down, so again it will get back to normal state and the alarm will stop ringing. Okay, so this is the next example. So what is the third example? This thing, I think all of you have seen this, right? During summers what happens? During summers, as in the summer day, the temperature is high. During the summer the temperature is high during the day time. Okay, so what happens on the time in summer? The iron parts of the railway track, they expand, and to avoid any accident due to this expansion, the engineers what they do, between two joints they leave some space. So if the iron expands, there will be no accidents. Okay, this is the reason why in between two railway paths there are some gap in between this. Okay, liquid thermometer. Okay, whatever thermometer people use, liquid type of thermometer, these are also good example of expansion of liquids on heating. Because if mercury, okay, in thermometer what we have? Mercury we have, right? In class this chapter, I think this chapter we have read about thermometer, right? So in thermometer what happens? On heating, mercury will spread and we can get the reading of the thermometer. So this is also a good example of how liquid expand on heating. Okay, so this is for today. On the next class we'll discuss about the next property of different materials. Okay, so this is for today, students. Thank you. Next class we'll discuss further.